time off to join our SheShares for functional programming. If you know of friends or classmates who will be joining the session, do give them a quick ping so that they know that we'll be starting off soon. As we wait for more people to trickle in, here's a shout out to our socials. I'm guessing you all are a part of our Telegram group. We also have an Instagram page where we announce our events and post updates regularly. Please do give it a follow if you have not done so already. We have some surprises coming up on our socials, so stay tuned. Um, for our socials, we have started a Humans of Wit where we feature your inspirational stories. So if you have anything which is inspiring or something which you want other women to know about, uh, please do share it with us. You can find more details on Humans of Wit at our socials. A super good evening to all of you. Thank you for joining us today as we discuss all things functional programming. I'm Srishti Arora and I'm glad to be the moderator for today's session. Here's a quick rundown for our schedule for the next 1 hour or so. We will first be introducing women in tech and SheShares, followed by a short introduction by our speaker. We will be learning about functional programming from Ms. Kanika. We shall then have an open house for question and answers, a photo taking sessions, and a couple of announcements. I'm a part of Women in Tech at NTU. We are the first student-initiated female-focused event committee under NTU OSS, and we created this platform for our fellow peers who are passionate about tech and want to get into tech regardless of their major. Our club envisions to create a healthy and vibrant environment in technology, and our mission is to empower and inspire all students through a collaborative and nurturing environment. A cordial welcome to the 6th edition of Women in Tech SheShares. SheShares is a bi-weekly women-led platform where we invite professionals from various fields of technology to share their journey with us, give us an insight into their field from a woman's perspective, and answer all of our burning questions. This is the 6th edition of its kind as a part of the SheShares series, but today's session is special since it is being conducted in collaboration with TGIFHacks. It's going to be all about functional programming. You can ask your questions here. using this QR code or by joining us at Slido. So using Slido, you can enter your questions anonymously, which will be answered at the end. You can either log on to slido.com and enter the number 45962 or scan the QR code and you will be redirected to the page. We are super excited to have with us today a woman in tech who is here to share her expertise with us in the area of functional programming. I'm sure if the event were live, we would welcome her with a huge round of applause, but with the same warmth, I welcome Kanika Jain. She is a software engineer at PayPal. Kanika, would you like to introduce yourself?
Kanika, you're on mute.
I'm sorry. Hello, everyone. Very good evening to everyone. Thank you for giving me this opportunity. I'm a senior software engineer at PayPal, and at PayPal, we build solutions which allow people to pay and get paid. So the portion that I'm responsible is basically moves money all around the world. So money moves from one financial institution to another financial institution. And I take pride in this because I feel it's my code that is making it possible. So it gives me an immense joy when I say that. Apart from working as a software engineer at PayPal, I'm also associated with an organization called Grace Hopper Celebration India Conferences. We call it as GHCI. So they organize conferences every year. And apart from that, they also have some other activities to promote STEM among women. So I'm associated with that for, I think, from 2016. I've been chairing a track over there. That's something technical I do apart from working at PayPal. That's all about me. Thank you.
Thank you so much for joining us today, Kanika. I feel it's the right time now to dive into functional programming, so I hand over to you to take over the session.
Sure. Thank you, Srishti. So let me try to share my screen. And my voice is very clear, right?
Yeah.
Okay, great. Okay, can you all see my slide?
Yes.
Okay, great. So I'm going to give you an introduction to functional programming. There is a lot to it, but I'm going to just give you a 101 in functional programming in this session. And I hope this session helps you in building a functional mindset. You should be able to start thinking in the direction of functional programming. That's the goal I have with this session. Yeah, this was about me, which we already did. Moving on, this will be the agenda for today. So among these, the highlights would be understanding what is functional programming, what are the key principles of it, and how we can write a functional programming program using Java 8. We will also write one example with that. So starting with the things. I'm not sure how many of you are from computer science background, so I'm just going to give a quick revision on what is programming language and what is a computer program. Programming language is computer language using which the computer programmer writes a program, and program is something which looks like this. So on the screen, whatever you are seeing on the right side is a simple computer program. These are basically the instructions using which we make computer do things. Also, these instructions are also meaningful for a person who is going to look at this code and trying to who is going to modify this code in future. So basically the code maintainer. So in any computer program, we have these basic items called variable, function, loops, if-else, and if it is object-oriented, we have classes, etc. And what we usually do in a computer program is we take some input, we try to modify, that is, we try to transform that input, and whatever data we don't need, we discard that data, we filter that out, and then we generate some output. And that's what most of the computer programs are doing. If you still don't get what is a computer program, a simple analogy for that would be, let's say if you want to bake a cake. So all the ingredients that you have, they corresponds to the variable. The quantities of each of the ingredient, let's say you have 6 eggs, so that becomes the initial values for the variables. The steps that you have in the recipe book, they becomes the instruction for what you want the computer to do for you. And at the end, when the cake is almost about to bake and you take a knife and try to poke it on the cake, right? At that time, you are actually trying to execute an if-else conditional statement. You're trying to figure out whether the cake is done or not done. So that's the idea about a computer program and programming language. Now, before we jump into functional programming, I would like to share my story, how I started working with functional programming. Like most of you, I also studied in my college the structural programming and the object-oriented programming. I never heard about something called functional programming in my college days. And I was practicing object-oriented programming for a while. But last year, I was asked to build a system. Now, this system need to compare 8 different type of data, which is spread across 9 different type of tables. And each table, again, then have 6 plus column. So the system, what my system need to do is, it needs to find out the inconsistencies of the data across all these tables. And if there are any inconsistencies, it needs to flag them out. The simplest approach to this problem would be, like, you are going to have more than 200 plus if-else and null check conditions in your code. Unfortunately, or I would say fortunately, I'm a programmer who dislikes if-else. Whenever I have to put if-else in my code, I think 100 times. So I dislike if-else because they initially look very simple. It's just an if condition. But eventually, as your business grows, as your business logic also grows, and then those simple looking if condition, they become evil. They get very complex. And tomorrow, when a new programmer has to work on your code, they face nightmares. So I was looking for something. I was wondering, like, how can I write a computer program which is easy to read, easy to maintain and expand, and it doesn't have anything called accidental complexity, and it is also works perfectly fine in the multi-threaded environment. How can I do this? And all the answers lead me to one thing called functional programming. All my Google searches, all my research lead me to functional programming. Also, I also had a technology constraint. I was supposed to use only Java 8 and Oracle, and that's where, like, you know, all answers, everything was diverting towards functional programming. So what exactly is functional programming? Is it a new programming language? Or if my code has too many functions, does that mean it is functional programming? Well, the answer is no, it's not. Functional programming is actually a style of writing the code. It's declarative in nature. What declarative means is, to my computer, I will instruct what I want to solve. I will not give the minute instructions step by step of how I want to solve my problem. Let's look at some examples. Over here, we have two styles of programming. One is imperative style, another is declarative style. So let me get the laser. Yeah. So the imperative style, which is on the top portion, here, what I'm trying to do in both the programs is I want to find out the count of attendees, which are of each attendee categories, how many of them are student, how many of them are professional. That's what I want to count in each of the program. But here in the imperative style, I'm not only telling my computer to do that, but I am also giving the steps. For an instance, I have to set the counter for each type, and I have to loop through the list of attendees, and then I have to provide the conditional clause as well to decide which counter I need to increment. So that's the way how we have been coding in imperative style paradigm, which is what is in object-oriented and even in the structure. Now the code at the bottom, it is declarative. Here I am simply telling, give me the attendee type and their respective counts. That's all. And the program will take care of it. The computer will take care of it. And this is very much what we have been doing in SQL queries. So SQL queries are declarative in nature. Now the question is, can we do this declarative kind of programming using Java or C++? The answer is yes, we can. And that style of programming is what we call as functional programming. So just like any other programming paradigm, functional programming also has some principles. These are the 5 basic principles of functional programming. Let's see each of them in detail. The first principle says functions are higher order and functions are first-class citizen. What that means, you can pass a function to another function as an argument. You can create a function within a function. You can assign a function to a variable, and you can return a function from a function. Actually, we have been doing all these, but with one difference. Instead of function, we have been using variables or object. We have been returning objects from a function. We have been assigning one object to another. We have been creating multiple objects within a function, and we have been passing objects as argument to the function. So I will defer now for the example. We'll see an example of higher order function and first class citizen functions later in this session. So you have to always remember in functional programming, it's the function that has higher privilege. That's what the basic, that's what this principle means. Next is functions need to be pure functions. What are pure functions? Pure functions are the functions which do not change the input or member variables. They do not depend on anything that changes. They don't have any kind of side effects because nothing external is getting modified anywhere. And for the same input, they will always give you the same output. It doesn't matter how many times you execute it. Let's see examples. So here on the top, you have an example of pure function. I'm passing an argument called string name. So basically a name I'm passing, and I'm appending it to another string, and I'm returning a new string altogether. My input is not getting modified here. Also, no matter how many times I'm going to execute this function, the output is also going to be same for the same input. And it is not depending on any external thing. Now let's see an impure function. Inside an impure function, over here, up till this point, everything is same as the pure function. However, this part here, I'm trying to append a timestamp to the string that this function is going to generate. Now timestamp will change in each execution. So this function is impure function. One use case of where we are using impure function would be when our application, the portion of our application where we depend on any kind of database operation, when we want to get some data from the database. All those scenarios are the thing which are impure in nature because you are dependent on some external factor to get the result. So your result will not always be the same. Next principle is chaining of operation. Now, as I told earlier in this session, in a computer program, we usually transform our input, we remove the unwanted data, and we converge to a single output. These things are called as map, filter, reduce, or collect operation. And in any functional programming language you take, you will find these functions. So map, filter, reduce, or collect. Each will have its own implementation, but you will have something to represent these. And how we use them in functional programming is something depicted here in this example. So in this example, this is written in Java 8. Let me explain what I'm doing in this example. I'm taking a list of integers as an input. Now that list, I'm converting that list into a stream. At the moment, it's okay if you don't understand stream. Just remember, instead of list of numbers, I'm using a stream of numbers. It's kind of similar in nature. It's not exactly the same, but to understand this example, you can believe it's kind of similar. Now that stream has these set of functions. We have filter, we have map, we have sum. At the filter thing, we are saying that remove any odd numbers. This expression is going to evaluate if the number is even or not. So basically, it will allow only even number to go to the next step. So all the even numbers from this list are allowed to go through in this sequence of operation. And in the next step over here, I'm going to compute a square root of that even number. Because a square root of an integer is always going to be a double, hence I am using map to double. And after that, I'm summing up all the square roots of the even number. So this kind of chaining of operation is very familiar thing in functional programming. Now, if you think about it, we can do this kind of chaining if and only if our functions are pure functions. Let's move on to the next principle. It says avoid explicit assignment. Now, this is something very weird because from the day when I started programming, we have been doing assignment operation. We have been saying variable a equal to 10 or something like that. We have been doing that. So is it possible to write a program without having any assignment, any explicit assignment? The answer is yes, and that's what we do in functional programming. Now the question, the program that you see on this side of the screen is our imperative way of programming where we have at least 3 assignments. This is one assignment, then this is another assignment, this is another assignment. So in functional style, how I will write the same program without having any explicit assignment. Let's see that. Okay, so here, if you remember from the chaining of operation, I have picked up filter, map, and sum, and I have introduced these 2 new things. Now this int stream iterate is kind of representing my for loop, where I'm saying you start iterating the stream, starting with the value 0, increment it by 1 every time. And by the way, I just need first 10 values, which is what this limit is saying. So it is equivalent to this for thing, whatever we are doing inside this for loop. And then I'm applying filter and I'm doing the map. Again, in the map, I'm saying, okay, I want to multiply my input by 2. Again, in the filter, I was picking up only even numbers, and then I'm summing up. So I'm generating a sum of double of the even numbers in this program. There are no explicit assignments happening in this piece of code. Now I have told you that we are saying avoid explicit assignment because I'm going to use Java. But in case if you are going to work on any purely functional programming language, right? In those languages, assignment operation is completely prohibited. So if you are using a purely functional language such as Scala or Groovy, then this kind of statement, input integer output equal to 0, this statement is not allowed. The compiler will throw exception. So our last principle is something called lazy evaluation. Lazy evaluation, it simply means that do not execute something unless you really need it. And this is not something new to us. This is something we have been doing in our imperative style of programming as well. What it means is, if you have a condition like this, right? You have an if block which has two conditions, they are separated by OR operator, then you won't execute condition number 2 until the condition number 1 is false. For all the time when condition 1 is true, you never go to condition number 2. So this is a lazy evaluation behavior, and this has been extended in functional programming. Let's see how it has been extended in functional programming. So here, again, this is using Java 8, and it has something called int stream, which is an integer stream. In using this integer stream, I'm providing it an input of a few numbers. In the second line, which is peak, I'm kind of printing these numbers. And then I'm multiplying these numbers with 3 in the map operation. And at the end, I'm going to say all match, where I'm looking for even numbers. What it means is, when I multiply my input with 3, then whatever is output, is it even or not? That is what it is going to check, this condition. And if for all the elements in this stream, whenever I multiply by 3, if I get an even number, then I'm going to get an output as true. This variable all even will be evaluated as true. However, if you look closely, here we have 7. So if you multiply 7 by 3, then it's going to be a false, and a false will be returned. So let's see how the output of this program will look like. So here you can see, because we were printing before multiplying, you can see 2, 4, 8, and 7. But what happened after 7? The answer is, because stream is lazy in nature and we are looking for all numbers to be even, the minute we encountered first number which is odd, it exited right there. It did not evaluate rest of the data. It did not go through the rest of the data. So that's what the lazy evaluation means. Now, again, the lazy evaluation it's kind of dependent on the chaining of operation and functions being the pure functions. Now, at this point, I think I have concluded on all the 5 major principles of functional programming. Are you guys okay with going further, or you guys want to take some break? What do you say? Shall I continue further?
Does anyone have any questions you would like to ask Kanika?
Yeah. Let me know if you guys have any question. We can check that.
Okay, I think we can continue, Kanika.
We can continue? Okay, let me continue then. So here is a recap of all the 5 principles about functional programming that we have discussed so far. Functions are higher order and functions are first-class citizen. Functions are pure. We do chaining of operation, we avoid assignments, and we evaluate lazily. These are the 5 principles. Now let's see how we can write a functional program in Java. Java is actually an object-oriented language. It was not supporting functional programming until Java 8 came into picture. And with the popularity of functional programming, most of the other conventional languages, even C++, Python, etc., they are providing the libraries or syntax to support functional programming. So these are the 5 basic things that we have in Java 8, which are meant for supporting functional programming. I'm going to cover first 3 of them, and then we will see the example, and then we'll get to know how the functional programming principles are applied in Java. So let's start with the first thing. First one is the functional interface. What are functional interface? You guys are aware of interfaces, right? I hope you guys know what are interfaces in Java. Okay, great. So functional interfaces are special kind of interfaces which have exactly one abstract method. And they have been introduced as part of Java 8 so that we can have functions which are first-class citizens and functions which are higher order. So functional interfaces in Java 8, they can be categorized into 5 different categories, which are listed here. And in each of these categories, we again have variants based on the data type that we are working on. If we are working on only integers, then we have something called int predicate, etc. And based on the number of arguments with which we are working on. So if you have 2 arguments, we will have by function, by consumer, etc. So based on that, we have the variants. Now let's understand what are these 5 categories of functional interfaces for. So first one, which is predicate. So if you have a scenario where you want to evaluate something which is true or false, like in our examples we saw, we were evaluating whether the number is even or not. At that time, we are implementing this predicate interface. Now, these are the abstract method of each one of them. Then the functional interface. If there is a scenario where you want to transform your data from one data type to another, then you might be depicting the behavior of functional interface. If you have a scenario where you want to transform the data, but your data type of your input and output both are same, then you might be doing something called operator behavior. Then if you want to instantiate something, you want to get an object of certain type, at that time you will be using a supplier. An analogy would be your constructors. Then regarding consumers, if you want to consume a particular type of data, then you have a consumer behavior. Simplest analogy here would be the printf statement. It consumes what you supply to it. So how do we implement these functional interface? We'll get to know about that in a short while. Lambda expressions. So to understand lambda expression, let's first understand what a function is. A function usually has 4 parts, something called function name, argument list, body, and return type. Now, from this format of a function, if you pick 2 most essential parts, which are argument list and the body, and you put them into this format, like argument list goes inside the round brackets, followed by arrow operator, and then you have the body. Then this kind of syntax is what in Java we call as a Lambda expression. What is a Lambda expression? It is essentially an implementation of an abstract method of a functional interface. Please remember, Lambda expression can only represent an implementation of an abstract method. Other methods cannot be represented using a Lambda expression. And again, it's an implementation of the function of the abstract method. Now, why do we have Lambda expression in Java? What's the purpose? Where do these Lambda expression actually fit in to our 5 principles that we learned about functional programming? The answer is these can be used in passing a function as a parameter to another function. So to make the function as a first-class citizen, we can use the Lambda expression. Let's dig deeper using an example. So here, let's look at the left side of the slide. In this particular portion, what we are doing is we are providing an implementation for the run method. Run method is an abstract method which belongs to runnable interface. Now, runnable interface is one of the very old interface in Java. However, starting with Java 8, they added an annotation on top of this interface that was @functional interface, which implied that runnable interface can have exactly one and only one abstract method, a method without no body defined inside an interface. So run method is that abstract method belonging to runnable interface. And as part of the implementation over here, all we are doing is printing one print statement. Now, because it is an abstract method of a functional interface, let's try to write the same thing using a Lambda expression. And this is how a Lambda expression should be. You should have argument list followed by arrow followed by body. So from this particular portion, we don't have any argument in the run method. So we'll just take the empty round brackets and we'll keep them here. Then we add the arrow operator. Then because its body has just one line, we'll just copy this whole line and we keep it over here. This now becomes our Lambda. And because this is an implementation of function which is being passed as a parameter to a constructor, that means this Lambda is the first order function, first class citizen, and the constructor thread is the higher order function. A higher order function is a function which takes another function as its parameter. So thread here is the higher order function. And the parameter function which is passed to it becomes the first class citizen, which is this Lambda expression. So using Lambda expression, you can see my code has become so short, right? Like this was a bit confusing. And now here it's just the implementation of the only abstract method that is available in the interface. So this is how we use Lambda expressions. Next is the Stream API. Now, Stream API is a special API in Java 8. You can consider it to be bit equivalent to a super iterator, but it is working on a infinite source of data. So there is no end to it. It is like a stream of data coming and there is no end of data for that. Now, streams, because they are specifically designed for enabling functional programming, they are lazy in nature. So it means that you don't have to see the entire data set to evaluate something. Depending upon what type of operation you are working on the stream, you can get the result much faster. You don't have to wait for the whole available input. Also, inside the stream APIs, there are a bunch of pure functions which are defined so that we can do our filtering of the data, our data transformation, and reduction operation as well. So these are map, flat map, for each limit, filter, etc. More details you can get about the API from the Java doc. We will not be seeing that, but I'm just going to repeat the same example here, which we saw earlier. We create a stream from a list of integer. We create a stream, and then on that stream we call its methods filter, map, sum, and it is a chaining of operation that we are able to do over here. The next API that has been introduced is something called collector APIs. Collector API on a very high level is something which we can use to build to do the accumulation of results for summarizing purpose, for counting purpose, etc. Or if you want to do some group by kind of stuff, then this API is very much useful. We will be seeing this API further in our example. Next is the optional API. Now, when you write Java code and when you have the objects which are actually composite object, meaning you have one object inside another object, then you have another outer layer of object. So it's kind of nested object sort of scenario you have. In that case, you don't know when any one of your object may become null. Sometimes because of the data or the input, for any damn reason, any point of time, any of your object can become null. So usually programmers, they add null check in their code, and that again grows very ugly. So to prevent that, Java has provided this optional API. And again, if in this optional API, you have various pure functions. You have something called if present. So if there is a scenario where you want to execute some portion based on whether your object is present or whether your object is null or not null, right? So if the object is not null, you want to execute something that you can put inside if present block. Then there is present, which is a Boolean thing. Then you have or else throw, or else get, etc. So depending upon what you want to do, you can pick up the corresponding function from this API. Here is an example of the optional API. So on the left side, what we have is the code without having the optional API. And on the right side, we have the code with the optional API. We are basically working on an object which is having this kind of structure, and then that objects of this kind of objects are stored in a map where we have car owner name and a car. So we get the car out of that map, and then we check whether our car is not null. Then we are fetching the list of trunk content, this thing, and then we are checking whether the trunk content is not null. Then we want to put this printf statement. So kind of 2 layers of null check we are doing over here. Now, if we want to achieve the same thing using the optional API in Java, here is how we can do that. So we get the car at this instant. So we have declared an optional object, and this is a factory method which gives you that object, and then you get the car from the owner, then you get the trunk contents, then you prepare a string with that, and if that string is not empty, then only it gets printed out. I know it may look very scary at the moment, but if you practice with optional API, it may actually become very simple. And personally, when I got to know about optional API, many of the code that I have been writing, it got super simplified because we do have the complex objects, the composite objects, and then we often have to handle the null pointer exception, which happens out of nowhere. So these are actually the problems which, if you work in any professional level software development, if you do, you will definitely face these. So we know the 5 principles of functional programming. We know 3 basic APIs or the syntaxes that have been provided in Java 8. So now let's work on an example of how we can write the functional code. In this example, we are going to prepare a program which is going to count the frequency of word after reading the word from a text. And this text is coming from a file. Now, most of you at this moment would be thinking that if we want to do this, we have to open a file. Then when we open the file in read mode, we have to read line in the file. Then we have to split that line into words, and then we have to count the occurrence of each word, and we have to store that frequency and the word in a hash map sort of thing. So we will do all that. Now let's see how that works in an example. I do have the code in the slide, but I would prefer sharing it on the IDE. So let me share that. Just give me a moment. Are you guys able to see my screen?
Yes, we can see that.
Okay. Okay. So let's first implement this word count concordance problem using our known imperative style. So this is the code for that. Here, what we are doing is we are opening the file, and then at this statement, we are reading it line by line. And every time we read a line, we check whether it's null or not. And then we just change the case of all the words in the line to uppercase, and then we split the line into words. We have to collect all the words into an array. We loop through an array and prepare our frequency map. That's what we are doing over here. And in this part, we are actually storing that map. I think I missed one thing. I'm supplying the file name as part of the argument to this function. And this is the caller code where I'm doing that. So I hope this thing is kind of clear to you guys. It's reading a file line by line, storing the data into a map. Before that, we will split the line into an array of words and count their occurrences. Okay, now let's see how we can write the same thing using functional programming. So here we are. Again, the caller code is kind of similar, and this is our method where I'm taking the file name as an input. And what I'm doing here, I'm calling something like this. What does this do? This particular line actually opens the file in read mode and extract lines from the file and supply them in form of a stream of lines, or rather, with respect to the data type, these are stream of, it is a stream of strings, because a line is essentially made up of string. And then for each line, we break each line into the words, And instead of collecting them as an array, we are directly collecting them as a stream of words at this place. And then we are removing if any word is blank. And then we are converting the words into uppercase. And at this stage, we are collecting them. So we are actually preparing the map, which is a map of string and the long. So it is like word and its frequency, word and its frequency. So you will have a table like this in the memory at this point. Now, after you have that, you again convert the map to set and set to stream, and then you print it out. Okay, I spoke a lot of things. Let's again revise what we are doing in this example. We are reading the file line by line. From each line, we are converting, we are getting the words. We are throwing out the words which are blank. We are converting the words into uppercase. And then we are preparing the word frequency map for each word, how many times it occurred. And over here, we are printing them. That's all we are doing. Okay, now let's execute both the program and see the output. So I'm first executing my imperative style of it, and let's run it. And this is how I get the output. Let's look for the word B. It occurred 154 times, and it took around 997 milliseconds. Okay, now run the same program in the functional style. Okay, here again, it took 154 times. It occurred 154 times, and I don't see how much time it took. I missed that. Anyways, but you got the idea. The outputs are coming same. So if you see this code and this code, I believe for most of you, this may look like a very familiar code. So because you are familiar with this style of programming, it may sound easy at the moment. But trust me, this is not that easy to read. Rather, you are doing multiple operations unnecessarily, which are like you are giving the instruction. You are even managing the handling of file. You have to take care of the end of the file. You have to iterate over the file in this while loop. And again, you are iterating over the array. So all those minute things you have to handle. But your goal is to find the word frequency. And here in this program, you are even providing the instructions of how to do. In this particular part, however, if you see, you are giving just the clear instructions. You are not telling how to handle the end of the file stuff and all. And here, let's say, let's understand how this program is following the functional programming principles. First of all, this flat map, filter map, all these are the higher order functions because they are taking another functions as an argument. Now, all these lambdas are nothing but the implementation of some extract method. For an instance here, right, this word arrow not word dot blank is an implementation of the abstract method present in the predicate interface. Also, we have done the chaining of operations over here. Now, let's say we want to run this program in multi-threaded environment. How will you do that? How much would be the code change? The answer to that is this. If you add that, then your program is going to run in multi-threaded way. And we can just do that. Yeah. So it ran in multi-threaded way, and again, my output result is the same, 154 times. And all these methods are pure functions. We do have lazy evaluation over there, and there are no assignments. So we are basically covering all the principles of functional programming in this small program. Now I'll get back to my deck. Just a minute. So here, I think by now you would have guessed these are the advantages that are clearly being called out from that example that we saw. So I'm just skipping this. Why functional programming has become so popular these days? The reasons are like we are in the age of big data and edge computing. We have way too many applications and devices that are generating infinite data continuously. So when we have so much of data, then applying the old style programming may not be the efficient way. Also, at this moment in college, you may not understand the importance of readability, but the day you step into corporate world and you are asked to fix a bug, you will understand how important it is to address the readability. We just saw an example of how to run a program in parallel manner using functional programming, and it's so easy. And because functional programming uses pure functions which do not have side effects, that means it is kind of safe, which implies we can actually make use of our multi-core hardwares.
Sorry to interrupt, Kanika. We have a question here.
Okay, sure.
Is there any library that we need to import to call the functions like .parallel and stream and the other functions which you used previously?
Yeah, so all these are present. First of all, if you have to use all this, right, so you have to have at least Java 8. So your JDK version, ensure that you are running Java, at least Java 8. The higher, the better it is, because with the advancement, things are getting much, much better. Now we have Java 15 actually, and there is Java util.stream, and then Java util stream dot, again, the other type of streams you have. So those are the imports that you can do. So you basically need stream API, which is present inside the Java util stream. That's the package. Is that clear?
I think that answers the question.
Okay, great. So we are almost reaching the end, and here are some tips I would like to give you so that you guys start building up the functional mindset. Just give me a minute. Playing is going. Okay. So whenever you are writing functions, right, try to make them pure. Do not try to mutate data. Try to transform the data. Then if you're using Java specifically, then instead of using loops and iterator, try to use stream. However, using stream is not always the option. Okay, so you have to actually judge when you should use stream, when you should use the loops or iterator. For an instance, the example that we saw for concordance, there using stream was making more sense. But if I take the simple example in an array of 10 numbers, find the even number, definitely using stream doesn't make much sense in that scenario. So you have to judge that. This is now the next step is, irrespective of whether you are doing the functional programming or not, whenever you have any kind of naming, be it variable, package, or function or classes, put meaningful names. That will help you in long run when you join any corporate. Try to keep your functions as small and simple as possible. So the minute you see the big complex function, try to split it into multiple small functions. And if you really want to apply functional programming, then try to think in the chaining of operation direction. Is it possible in your use case? If it fits, please do that. Next is avoid assignments. So whenever you are trying to do any assignment, right? So in that case, please try to think if you can use a Lambda expression instead. And if you follow these tips, you will eventually land into functional programming. So as I said before, I mean, you have to really be careful when to use what. The programming paradigms are not mutually exclusive, they coexist. So depending upon what problem we are trying to solve and what are our other circumstances, we have to choose between them. So don't jump into functional programming because that's what is happening today in industry, but really understand where you need to use a functional style of programming and where you shouldn't be using it. And as an engineer, as a developer, as a programmer, always write good optimized code which uses the features of the programming paradigm you are following. This is because the languages are designed for that specific programming paradigm, and they are having all the optimizations which are like, scaling for the specific hardware and all those kind of things. So really use those features. So that concludes this session. Thank you all for patiently listening. I hope you would have learned one or two concepts about functional programming by now. Maybe we can start the Q&A.
Thank you, Kanika. It was a wonderful presentation, and I'm sure everyone would have something to take away since we are not taught functional programming in university. So,
Yeah.
I think we can start with the questions.
Okay.
This liked question right now is, only Oracle and Java are used in PayPal?
No. That is, I mean, like in PayPal, we have a variety of tech stack. The portion where that I was working has a tech constraint, but otherwise we really have Scala. I don't think we have C++, C#. We are usually working on open source stuff. So we have Scala, Java, Oracle, Python, React and Angular. All these things we do have. So depending upon what portion of the program or what layer you are working on, like if you are working on mobile apps, then you have different things altogether. So it changes.
Okay. So the next question is functional programming used at PayPal?
Yes. So initially, PayPal was a C++ company. We started with C++. Then we adopted to Java. And when we adopted to Java, at time it was Java 7. Java 8 was not out there. It was back in 2011 or something. So these days, like we are going towards higher end of Java. And because we are going to use higher end of Java, we are adopting to functional programming. You will see a mixture of code, but whenever possible, use what you can use the best.
Okay. So would you recommend using functional programming in the coding test?
So yeah, that is something you will be facing. I would suggest when you are facing the interviews, because you guys are fresher, you have luxury of not using functional programming. if you are showing that you know functional programming and solving a problem using that, it's a great plus point. But because for the college hires, usually we look on, can the candidate code? Can the candidate think? So at that time, no one is expecting you to write functional programming. But yes, I am at the stage where if someone tells me to write the program, I would prefer going for functional. My brain is no longer thinking in the other style. So that happens.
Thank you for sharing that. What are some of the research projects that PayPal is doing?
Oh, that one, I'm not really. So we cannot. So first of all, I'm not the right person to answer that. I deal with the business projects, so we don't have that kind of research, at least in my area. But we do have innovation teams in PayPal, and they do a lot of research. One example would be PayPal has invested in exploring quantum computing. So that is one of the research they are going. So under the innovation lab, a lot of research goes on.
Okay. Is there any change in time complexity if we use functional programming?
Time complexity, it won't be always with the time complexity. It simplifies the things. And as you saw, it removes the nesting of the loops to some extent. So there is always an upper edge. However, space can be a problem. Sometimes, because we are saying we are working with pure functions, so there can be some rare scenarios where you may get into the space trouble, but not always. For most of the cases, it is sufficient.
So
so one more thing is, because you can write the parallel code, right? So you can make the code into concurrent very easily in functional style. So when you make it into the parallel execution, you definitely see a faster execution.
Okay.
So
Thank you. So PayPal is all about payment software projects.
Well, I would not say that is completely true, because we are a payments company, but we are also a technology company. So we do invest in a lot of technologies, and even to have a company which is building payment software, you need to have some kind of infrastructure. So there are teams who work on building that infrastructure. Then we also have teams who work on security, because security is one crucial aspect to be worked on. So it depends, but yeah, our bread and butter is coming from payments. That doesn't mean that we don't invest in other areas as well.
Right. So our next question is blockchain and cybersecurity in PayPal. I have a stereotype that in PayPal some people did a lot of research or literary reviews more than programming.
Yes, that is very much true. We do have people who do a lot of research. So it depends on which team you are in and what kind of work is expected from you. Yes, it very much. We do have folks who work on research projects.
A lot of questions coming in for the research part. PayPal, Azure versus AWS. So the question is asking,
okay, what cloud services we are using.
So sponsor internal people to go for certs and courses, or there are internal courses as well?
Okay, I'll answer the second question first. PayPal does sponsor a lot of, they sponsor a lot of internal people to go for certification courses, even take university classes. And we do also have internal training courses. So it goes both ways. So we do have free access to Orally. And Orally is a good place to learn things. I personally learned things from there. I mean, this functional programming. So coming to the first part, Azure and AWS, I'm not aware, but we are using Google Cloud, definitely.
Why did Java replace C++?
Okay, so this is a company-wide decision. There are a lot of factors for this moving from Java to C++. I mean, moving from C++ to Java stack. Your things need to scale for the next generation. Like PayPal came into existence in 1998. At that time, people were coding in C++. And then you have to be what is available in market, how the things are changing in market, and you have to be thinking about the cloud infrastructure, right? So with all those things being fitted into things, the tech stack change happened in PayPal. We moved from C++ to Java, but we still have some portion of C++ left, which is going in phases. You do get, okay, the next part is it because Java is easier to work with Scala, big data? So we are working with big data and Scala, but those were not the only reason for moving to Java.
Okay.
Given another choice, would you want new graduate to learn Java or another language framework if you want to be hired? I would say at your level, if you know Python or Java or Node.js, that should be good to start with. And when you start as a software engineer, you may be knowing one language or two language, but when you as the year goes by, you have to keep yourself updated with the new technologies that are coming up. You have to pick up the languages because of the demands of the work that you are doing. So it is a continuous learning process. Some best programming.
Yeah.
Sorry. Yeah. I will let you read the question. That's better.
What are some of the best programming practices which you use?
Yeah. So some of the best programming, I think some of them I covered actually in the slide. Like using meaningful variable names, writing short functions, deciding the boundaries, what stays where, deciding what is the scope of one object, those kind of things I follow. And like, I usually not settle for one solution. I look for what all multiple solutions are there and what would be the best way to do it. As I said, I have a dislike for if-else. So I find excuses for not putting if-else and achieving the same in my code.
Is it because if-else is not considered a good way to code?
It's not like that. That is because I have seen the code, how it grows with if-else. I'll give you an example. Today, PayPal is supporting payments for like 200 plus companies, and we have things for 22 plus currencies. I'm just giving you a number. You can get the actual number from the site, but these are the rough numbers. Now, when you are working, when you are building payment solutions for so many different countries, right? Each country will have its own financial regulation. And those financial regulations need to be coded up in your business logic sometimes. And they keep growing bigger and bigger. And if you have an if condition which is made up of 5 other conditions, and then you will be spending a lot of time in understanding what are we doing. We have 5 conditions inside one if condition. Some is and, some is or, some is combination of it. How does this code works? You will be spending more than an hour in understanding that, and that very much happens. So right from the beginning, if you start if you have a practice of writing a code that you can read even after 10 years, I think then you are doing a great job.
Right. Thank you so much. Let's take the last question. How has your experience as a software engineer been like at PayPal?
So I I'm at PayPal for more than 8 years, which pretty much says I like working here. And it is very interesting because when I was hired for a C++ software developer role. And at that time, I did not know C++. So I learned C++ after joining PayPal. Then eventually we moved to Java. And at that time when we moved, I only knew the older version of Java, JDK 5 or something. So I had to learn the newer standards of Java. And now soon I know I will have to learn Python. So I'm continuously learning. And I like that part. And I get to do different style of stuff, which is interesting. So there is always something challenging. And whenever there is something which is always challenging, you really enjoy doing that because you feel wow when you complete one challenge. It's like you have cleared one exam and you're giving another exam. So that's what I like. And there is a lot to learn, different technologies to work on. And if you guys are research oriented, there is a lot of scope. And the culture is very happy culture. So you can do almost anything. It's all about you, how much effort you want to put. So, yep.
Seems like a very good experience. Thank you for sharing that. Since we had a few questions regarding research, could we have Solomon to take over and give his 2 cents?
Sure. Yeah, I think he will be the right person.
Hey, sorry. What's the question?
So the attendees wanted to know about the research which is going on in PayPal.
Okay, so it depends on which team, right? Globally we have the innovation lab, right? So for US based, they are researching on the blockchains and the other stuff that Kanika mentioned, right? About the future on how we can leverage quantum computing and stuff. Then for Singapore, we focus on applied research, right? Fraud detections, customer service, etc. So right, so all that we do is about how can we automate certain processes, right? And then at the same time, how can we improve our user experience, like security, right? If we are able to detect fraud before the customer even complain about it, or we detect their problem before they even contact customer service, then we could reduce the amount of call center volume, as well as improving the experience for both sides. Yeah.
Okay. Thank you so much for sharing that. And now, since we have come to the end of the Q&A as well, I think it's time for a quick photo taking session. So everyone who is not too camera shy can turn on their cameras so that we can have a photo.
Hi guys, don't be shy. You can come in and take a photo. Okay, I clicked a bunch of photographs. Officially, take it away.
Thank you, Surbi. And now, before we wrap up, we have a couple of announcements. So, hey, I'll just share my screen. Give me a second. Yeah. I hope it's visible now. So the first announcement is that Women in Tech is launching Humans of Wit. So do head over to our Telegram and Insta channel for more information. We are featuring you. And the second announcement is that Women in Tech is launching a monthly newsletter. So to join our mailing list, you can text Surbhi, Claire, or me on Telegram, and you shall receive a monthly copy. The last announcement is that Women in Tech is recruiting committee members for our next academic year. We have 2 positions available, Events Tech Director and Social Media and Marketing Director. So if you want to be a part of the committee, do contact us and we'll let you know the next steps. Thank you so much for joining us today and have a great evening. Thank you, Kanika, for sparing time out of your busy schedule.
Thank you, everyone. I hope you learned something today. Feel free to reach out to me. I've shared my LinkedIn details. And all the best for you guys. Thank you.
Could we share a copy of the slides with our participants?
Oh, definitely. Yes, yes. There is, I mean, whatever there I have kept is basically how I learned functional programming. So it doesn't have anything related to company as such. So you can pretty much share it. No issues.
Thank you so much.
Thank you.
Just a quick shout out for our socials as you leave. Stay connected with us, and we have some surprises coming up.
Thank you, Kanika. Have a great evening.
Thanks, everyone. Bye.
Bye.